All right. Hi, Dr. Iverson. My name is Greg Verone. This is the Cap2 Fatal Lactate presentation for Kin516 Advanced Exercise Physiology, and we're just going to dig right in. So today we're talking about lactate, which is a product of anaerobic respiration, or a form of anaerobic respiration. And then right off the bat, lactate should not be viewed as a metabolic waste product. Rather, it is an intermediary product, because it is recycled, as we're going to describe in a little bit. It is recycled and made back into glucose, which can be used by the body to create ATP. This is all done anaerobically, of course, and it's used during the Cori cycle. And the Cori cycle is just the cycling of glucose and lactate between skeletal muscles and the liver. It removes lactate released from active muscles and is used to replenish glycogen that is depleted from intense exercises. This prevents lactic acidosis, which is the buildup of lactate in the blood and in skeletal muscles under anaerobic conditions. Obviously, to an extent, there is a threshold. And then this is, of course, only during anaerobic activity. And as we're going to describe in a second, you're going to see gluconeogenesis and glycolysis occur simultaneously as this metabolic process is occurring. So here we're looking at the diagram that I created from a couple of my sources of the Cori cycle, or what's going to happen to glucose and lactate during anaerobic exercise. And so we're going to start with the blood. So the blood transfers glucose into the skeletal muscle. Glucose is converted to pyruvate via glycolysis, and that's going to create a couple of ATP for energy. But we don't have the ETC here, and we don't have the Krebs cycle, so that's going to be very limited. So pyruvate is then going to be converted to lactate via fermentation, where lactate dehydrogenase oxidizes NADH2 to NAD+. And so now we have this organic compound lactate, which is actually toxic to the body in high amounts. So our body's going to do something to get rid of it. And what it's going to do is it's going to transport it via the blood to the liver, which is, the liver is our mass detoxifier in the entire body. So it's going to convert lactate back to pyruvate, reducing NAD+ to NADH2, using lactate dehydrogenase, the enzyme again. And from there, pyruvate is going to transform or convert back into glucose, using gluconeogenesis. And gluconeogenesis is essentially glycolysis, which is the breakdown of glucose to pyruvate, in reverse. It's pretty much the exact same steps, just the reverse of it. And so now we have glucose in the liver, which is going to be transported back to the blood, back to the skeletal muscle, where we can start using it again. And then to just sum this up, this is all occurring at the same time. So blood is going to contain lactate and glucose at the same time, but one is going to the skeletal muscle, glucose, to be converted to pyruvate, then to lactate, which is then going to be transported to the liver to be converted to pyruvate, then back to glucose, all happening at the same time during anaerobic exercise, and this is what's going on in the Cori cycle. So how is this pathway affected by exercise intensity? As exercise intensity increases, anaerobic exercise increases, which means the body won't have as much oxygen, and there won't be as much oxygen in the blood and in the muscles, and so the body will end up using the lactate pathway at an increasing rate. And then how is the pathway affected by training adaptations? As the body adapts to exercises and intensities, the body's going to be more inclined to use aerobic metabolism, because more oxygen is going to be present in the body, in the bloodstream and in the skeletal muscles. And the body is going to be less inclined to use this lactic pathway, the Cori cycle, and the anaerobic respiration for energy because of the presence of oxygen. The last thing to cover on this slide, lactate versus lactic acid. Although they're used interchangeably in current research fields and tons of articles, scholarly articles, lactate and lactic acid are not the same. Lactic acid is the compound that is actually not found in any living system or living organism. That would be lactate. There's no metabolic production or breakdown of lactic acid within the human body. It's actually purely lactate. The body uses, creates, breaks down lactate specifically for this process, or specifically for the Cori cycle during anaerobic conditions. So this is the last slide we're covering for this cap. Can lactate be used metabolically? As we talked about, lactate is a product, an intermediary product that is created during anaerobic exercise. So at high exercise intensities, substrates other than glucose, such as lactate, may contribute significantly to energy production, and we talked about that, and that's the Cori cycle. So consequences of lactate accumulation on our ability to sustain exercise and other factors that may influence exercise cessation. The most popular theory is that lactate itself, lactate accumulation, leads to fatigue. However, newer findings kind of suggest that it may not directly be related to lactate, but more indirectly related to lactate because it reduces muscle pH, which leads to fatigue itself. But this is still controversial, and so a lot of evidence is supporting that lactate accumulation is what leads to fatigue. And the reason why it does this is because it reaches a threshold. So lactate threshold is the point during exercise when blood lactate begins to exponentially rise or exponentially increase. And what this means is that skeletal muscle is converting glucose to lactate, and lactate is entering the blood faster than the liver is converting lactate back into glucose. And so there's a higher amount of lactate in the system than there is glucose, and it just begins to rise and rise and rise. And at a certain point, this is what leads to exercise cessation. And it does this because it causes muscle fatigue. It's what causes the burning sensation in the muscles, and it decreases blood flow to the brain and skeletal muscles overall, essentially causing the cessation of exercise. So to give an overview of this slide, can lactate be used metabolically? We've shown that it is. It is an intermediary product that helps the body create energy. It is not used by the body directly to create energy, but it is used metabolically. The consequences of lactate accumulation, it leads eventually, as we hit that lactate threshold, it leads to the exercise or the point of exercise where we can't go on any longer. And then there are other factors that influence exercise cessation, although most research shows that lactate is the primary reason why we hit that point of exercise that we can't push past.